Hey, for those of you that might be having a little bit of difficulty with this naming of ionic compounds, this next section of the course, I'm just going to do a little bit of a tutorial here. It's going to complement what I'm doing in the lecture, just to kind of show you, those of you that learn best by seeing me work through some examples. I'm just going to show you how I'm going to convert the name of these compounds to the formulas. So first off, I'm going to take a look at the periodic table, and I'm going to take a look at the name of my compound, and I want to recognize that each of the atoms that are involved in these compounds, if I take a look at the first atom, you'll notice that it's written exactly the way it is on the periodic table. So for this first example, number 1, I just need to find sodium on the periodic table. So sodium is atomic number 11, and the symbol for sodium is Na. I'm just going to write that here. And if I take a look at sodium on my periodic table, I notice that in the top right-hand corner, it tells me that the charge on the sodium ion is a 1 positive. Now, you really don't need that reminder, because if we were to draw out the Bohr diagram for sodium, we'll notice that it has 11 electrons. So if I were to put those electrons into the appropriate energy levels for sodium, I would have 2 in the first energy level. I could just write that off to the side here. For sodium, it would have 2 electrons in the first energy level, 8 in the second energy level, and 1 in the last energy level. It would end up losing that 1 electron, and that's why it would become Na positive. All right, it would lose an electron. So again, the periodic table helps you, because in the top right-hand corner of the sodium cell, you'll see that it has a 1 positive charge. If I take a look through the periodic table now and find bromine, so bromine is on the other side of the periodic table. Its symbol is Br. If I take a look at bromine on the periodic table, well, I see it's got an awful lot of protons. The atomic number is 35, so it should have 35 electrons as well. I don't need to worry about how many electrons there are. I just take a look at bromine and the fact that it's in group number 17 on the periodic table. Remember, we said the last digit of the group number tells us how many electrons in the outer shell, the valence electrons. So bromine's got 7 valence electrons, which means it wants 1 more to fill. It wants to take on 1 more electron, to steal an electron, to have 18 electrons. And when it does, it's going to have a charge of 1 minus. Now, my job in writing the formulas of these ionic compounds is to make sure that all of the compounds are neutral, and that means that the number of positive charges and number of negative charges cancel each other out. So Na is a +1, Br is a -1. Therefore, I can write these two things together, NaBr, and they will be neutral, because as I said, Na is a 1 positive, Br is a 1 negative, so this turns out to be a neutral compound. All of the compounds are going to be neutral. Every compound that you're trying to write the formula for should be neutral. Let's take a look at the next one, calcium. Taking a look at calcium on the periodic table, the symbol is Ca, and we take a look at the top right-hand side. In that cell, it tells us it's a 2 positive charge, And again, you can figure that out by quickly sketching out the Bohr model, and you'll see it's got 2 electrons in the outermost shell. It wants to lose those 2 electrons. Remember, we said that 4 is the boundary. Anything less than 4 electrons, they want to lose those electrons. So if it loses 2 electrons, it's going to become a 2 positive charge. Chlorine is on the far side of the periodic table. It's in the same family as Br. So everything in that family, when it forms an ion, is a -1 charge. Now we'll notice that the charges here don't balance. I've got a +2 charge with my calcium, a -1 charge with my chlorine. I need to have these two things cancel each other out. And if I've got a 2 positive charge with my calcium, I'm going to need 2 Cl's, and that's what this little subscript means. It tells me I need 2 Cl's to cancel off the calcium. Because remember, the calcium is a +2 charge The Cl is a -1, and that's why I need 2 of those. Okay, because 2 times -1 will give me -2, and that -2 will then cancel off the +2 charge of calcium. Let's do another one, magnesium sulfide. So magnesium on the periodic table, Mg, it's got a charge of 2 positive. Sulfur falls in group number 16. And if I take a look at the group number 16, second digit is 6, it tells me that I need 2 more electrons in order to fill that outer shell. Remember, that outer shell can hold a maximum of 8 electrons. So if I were to draw out the electron configuration for sulfur, in the first energy level it would have 2, second it would have 8, the third energy level it would only have 6. It's looking for 2 more to fill. And that's what it does. It takes 2 electrons, and when it does, it becomes a 2 negative charge. So you'll notice that magnesium, when it forms an ion, has a 2 positive charge because it's lost 2 electrons. Sulfur, when it forms an ion, takes on 2 electrons and forms a 2 negative charge. So the formula for this compound is MgS. I need 1 of each. 1 magnesium gives away 2 electrons. 1 sulfur is going to take on 2 electrons. Let's do one more. Aluminum oxide. So I've got aluminum, or if you're from British extraction, aluminium, and oxygen. If I take a look at where aluminum lies, it's just below boron, group number 13, and it tells me that the charge when it forms an ion is +3. Sulfur and oxygen are in the same family, so I notice that sulfur, in the example above, has a 2 negative charge. Everything in the same family is going to have the same charge when they form an ion. Okay, so sulfur is a 2 negative charge, oxygen is also a 2 negative charge. So what we need to do now is we need to see if we can balance those charges. Okay, so we need to balance the charges. This is a little bit challenging because I've got a +3 here and a -2 here. So what I need to do is I need to think, what is the lowest common multiple between a +3 and a -2? So some simple math. Again, think of the multiples of 3, multiples of 2. 3, 6, 9, 12, multiples of 2, 2, 4, 6, 8. The lowest number they have in common is 6. So I need to ask myself, how many aluminums is going to give me a charge of +6? Well, if I had 2 of them, 2 times +3, that would give me a +6. And if I had 3 oxygens, well, 3 times -2, that'll give me -6. So the pluses and minuses are going to cancel out. All right, so on the left-hand side here, I have 2 aluminums. Each of the aluminums have a +3 charge. 2 times +3 gives me a total of +6 here. If I take a look at the oxygens on the other side, I've got 3 oxygens. So 3 times -2, each oxygen has a charge of -2. That gives me a -6, and the plus and -6's cancel out. So that gives you a little bit more detail on how you can write the formulas for simple ionic compounds. Ionic compounds that only have two components, right? 2 different elements that are coming together to form that compound. And we'll take a look at some more complex examples in subsequent videos.